Imagine a monster that isn't alive. It doesn't breathe, it doesn't have a heart, yet it can infect an entire planet's supply of life-saving medicine. In 1996, a drug called Ritonavir was a miracle.
In 1996, Ritonavir was a miracle. But in 1998, in a lab in Chicago, that miracle died. A single capsule wouldn't melt. It had turned into stone. Abbott moved production to Italy. But the moment the Chicago scientists arrived, the infection followed. It wasn't biological. It was a disappearing polymorph. One day you have a cure, and the next, it vanishes forever.
Impressive. Any thermal data?
Yes, here. Efficiency is up 10%.
Excellent. Let's run the simulation.
To solve this, we go back 170 years to Liebig and Wohler, two geniuses who hated each other. They made the same formula, but with different results. One powder was boring. The other would blast at a touch. They discovered isomerism. Arrangement is everything. Look at chocolate. Shiny and snappy is form 5, but if it melts and resets, it becomes dull, gray, and sticky, form 4. Ritonavir had fallen into an energy valley, a shape so stable that no amount of heat could pull it back. Ritonavir had fallen into an energy valley, a shape so stable that no amount of heat could pull it back. It spread via tin pest. Legend says Napoleon's army lost because their tin buttons turned to dust in the Russian cold. The Chicago scientists carried these seeds on their clothes, hair, and breath, destroying every factory they entered. 50% of compounds are polymorphic. Even aspirin has a hidden form. We are dependent on cures that could disappear tomorrow. Nature favors the stable. Next time you take a pill, remember, you're just one chemical mistake away from the end.